Now that you know what the alternating current AC is, and you don't only know about DC, we can actually go on and do solve a few problems with alternating current. So let's draw our circuit with a generator which generates alternating current. So as you can see, there is this kind of squiggly line, which basically means that this generator is generating alternating current. Now, I'm going to have an impedance, which is basically like a resistance, and another impedance here, and another impedance here. I'm going to define this current flowing through here as I. And my generator, as always, is V. Generator of voltage, monophase, alternating current. Well, voltage, but a voltage generator. Okay, so the problem is saying, in this case, the problem is saying that for the circuit on the left, working in AC, we know that V is 220 plus I 0 volt effective value. Z1 is 1 ohm, ZU is I2 ohm. Verify the energetic balance of the complex apparent powers and find the effective value of and the maximum value of the current. So there are quite a few things to do. Let's crack on. First thing first. Well, first thing first. I hope that you're already past your calculus 1 class, and I really hope that you're familiar with imaginary numbers, because we are gonna use this extensively during circuit analysis for alternating current circuits. So the first things that I'm gonna do is to find the total impedance, which I'm gonna call Z total, ZT. So the total impedance is gonna be 2 times ZI plus ZU. So Z total is just 2 times 1 plus I2. So Z total is 2 plus I2 ohm. Now, the second thing I'm gonna do is to find the current high, but it's gonna be a complex current. So I, the dot are to indicate that are complex. Well, but even if you are working in in this kind of circuit and we are working with sinusoids, so basically AC current, Ohm's law still apply. So the current is actually the voltage over the resistance, which in this case is the total impedance. As I said, impedances are, you can treat them like resistances. So I is 220 plus I0 over the total resistance. So 220 plus I0 over 2 plus I2. Now, I want to get rid of these imaginary number at the denominator. So what I'm going to do, if you have something like this, you can say, okay, this one is like saying A plus BI over C plus DI. So you have those two parts which are imaginary. So these actually becomes AC plus BD plus BC minus ADI, everything over C squared plus D squared. So in this case, we would have 220 times 2 plus 0 times 2 plus 0 times 2 minus 220 times 2I, everything over 2 squared plus 2 squared. So what do we get? Well, we get 440 plus 0 minus 440i, or everything over 4 plus 4. So this gives us 440 minus 440i over 8. Now I can just split the denominator and those two into two separate fractions. So this is like saying that it's 440 over 8 minus 440 over 8i. So that I can simplify those two, I can divide those two, then I get 55 minus 55i amps, since it's a current. Now, to find the effective value of the current basically means, the effective value basically means that you basically gonna have to calculate the norm of the real part and the imaginary part. So do you remember in linear algebra how to calculate a norm? Well, that's right. The square root of those two values squared added together. So basically the norm is IR squared plus IM squared. So I will be given by the real part squared plus the imaginary part squared, everything in under the square root. So I, in this case, will be 55 squared plus 55 squared. So I will be, well, let's see, 55 squared is 3025 plus 3025. So I is the square root of 6050. So I is actually, well, it's about 77.78 amps. Now, another thing I gotta do, because it was asked, because the problem is asking that, is I'm gonna find the maximum value of the current. So Imax, in order to find the maximum value of the current, you just have to multiply the current by the square root of 2. So if you multiply the current by the square root of 2, you get that Imax is the square root of 2 times 77.78. So Imax is, well, square root of 2 is about 1.44 times 77.78. So Imax is, well, is roughly 110 amps. Now, I found those. I have found those, so I'm kinda good. But there's still a few things that I'm gonna find, because the problem was actually asking me to verify the energetic balance of all those powers. And I only found the current and the maximum value of the current. So I haven't solved the whole problem yet. Now, to solve the whole problem, I'm going to do a few more things. First of all, I'm going to have to find the apparent complex power irrogated by the generator, and I'm going to use the complex conjugate of the value of the current. So Ag will be V times I, complex conjugate. I'm just going to use this symbol. So Ag will be 220 plus 0I times 55 plus 55I. So Ag will be, well, we're working with complex numbers for imaginary numbers. So those two, having those two is like saying having A plus BI times C plus DI. So we'll get AC minus minus BD plus AD plus BC. So AD will be 220 times 55 minus 0 times 55 plus 220 times 55 plus 0 point times 55 I. Running out of space here. So what do I get? Well, I get that Ag is, well, 230 times 55 is 1000. Well, no, it's 12,100 minus 0 plus 12,100 plus 0I. So Ag is 12,100 plus 12,100 I VA. So Ag is, we know that Ag is Pg, the power generated, plus IQG. So, which is actually 12,100 plus 12,100 IPA. Now I can find the apparent complex power absorbed by the line plus the user. So the Pi, we know that Pi plus Pu is 2 times Ri times I squared. So this will be 2 times 1 times 77.78 squared. So 2 times 6049.73, which is gonna give me 12,099.45 watts as power. Now Qi plus Qu is Xu times I squared. So 2 times 77.78 squared will be 2 times 6049.73, which is 12,099.45 VAR. So now I only have to verify the energetic balance, and I can do that because I can say that PG is PI plus PU, and I can say that it's 12,100, which is, well, it will be equal to what we have found here, um, which is 12,099.45. And yeah, you can argue that 12,100 is not 12,099.45, but I'm just gonna say that yeah, it's verified. It's 12,100 is about 12,099.45. So yeah, it's verified. So it's verified. It's pretty much the I just rounded while I was doing calculations. And QG is QI plus QU, so it's actually 12,100, which is equal again to 12,099.45. So for all our intents, 12,100, we can say that it's about 12,099.45 VAR. So again, it's verified. And happy face. So yeah, that's pretty much it for this problem actually. And yeah, the energetic balance is actually verified. I just rounded. It doesn't matter. But yeah, that's pretty much